Today, we're going to tackle something incredible, and something you do every single second without even thinking about it: perception. We are going to pull back the curtain on the amazing, complex way your brain literally builds the world you see around you.
So let's kick things off with a puzzle. How is it that you can spot a friend's face in a massive, chaotic crowd in an instant, but some of the most powerful supercomputers on the planet can still get stumped trying to identify a simple tennis ball? The answer to that question? Well, it's the key to understanding everything you experience.
So here's our game plan for today. First, we'll look at why just seeing something isn't as simple as it looks. Then, we'll get into why this is so unbelievably hard for computers to do. After that, we're going to uncover your brain's secret toolkit of shortcuts, and we'll see that seeing is really all about doing. And finally, we'll land on the big idea: your brain is, at its core, a prediction machine.
All right, so let's dive right in. The simple act of looking at something feels so automatic, doesn't it? Instantaneous. You open your eyes and boom, the world is just there. But what's really going on under the hood is a non-stop, lightning-fast process of complex problem solving.
See, at its heart, perception isn't just your senses acting like a camera, passively taking pictures. It's an active, dynamic experience. It's your brain grabbing all that raw data from your senses and running it through this process that's almost like a form of reasoning to create your reality.
Okay, check this out. Imagine this scenario. Crystal's walking on the beach and she spots this long, brownish shape way off in the distance. Her brain's first guess? Probably some driftwood. But as she walks closer, more information, more sensory data starts to pour in. The shape becomes clearer, she sees colors, and then, suddenly, her perception completely flips. It's not driftwood at all, it's a folded-up beach umbrella. That one moment shows you that perception isn't a static photo. It's a living process where your brain is constantly updating its best guess based on new evidence.
You know, this all sounds pretty easy for us, right? But that's the thing. If our brains can do this on the fly, why is it so incredibly difficult to get a machine to do the same thing? This leads us to the next big question. Why is seeing one of the hardest problems in all of computer science? Let's look at the huge challenges our brains solve without us even noticing. So first on our list of challenges is something called the inverse projection problem. Now, that sounds technical, but the idea is simple. The image that actually hits the back of your eye on your retina is a flat, two-dimensional pattern. The problem is, a nearly infinite number of different 3D objects out there in the real world could have created that exact same 2D image. Your brain's job is to figure out which possibility is the most likely, and it just does it, effortlessly.
And then, you've got the problem of objects being hidden or, incomplete. You have zero trouble recognizing your cat even if most of its body is hiding behind a couch. Your brain just uses its lifetime of cat knowledge to fill in the blanks. A computer, though? It often just sees a weird, couch-colored shape and a couple of furry ears. It struggles to make the connection.
And this one is just incredible. It's called viewpoint invariance. Think about it. You know a coffee mug is a coffee mug, whether you're looking down at it from the top, from the side, or even from underneath. It's obvious to you. For a computer to do that, it has to be trained with tons and tons of pictures from every conceivable angle. For you, it's just a mug.
Okay, so how on earth does your brain solve all these impossible problems like every single second? Well, it turns out it has this secret toolkit. A whole bunch of powerful mental shortcuts and principles it uses to make sense of a world that's messy, ambiguous, and constantly changing.
So the two big players in this toolkit are what we call bottom-up and top-down processing. Bottom-up is everything coming in from the outside world. It's the raw data, the light hitting your eyes, the sounds hitting your ears. But that's only half the story. Top-down is all of your knowledge, your memories, your expectations flowing back down to tell you what all that raw data actually means. Real perception is a constant conversation between the two. Okay, this slide is the perfect example of top-down processing at work. Just look at that yellow blob. Now that shape is physically identical in all three scenes, but you don't see a blob, do you? Your brain uses the context, the kitchen scene, the street scene, the person's leg, to instantly tell you what it is. You see a loaf of bread, a mailbox, a shoe. Your knowledge of the world is literally changing what you perceive. Your brain also comes with these built-in rules of thumb. They're called the Gestalt principles, and they're like the brain's factory default settings for organizing the world. Good continuation just means we tend to see smooth, flowing lines rather than jagged, broken ones. Similarity means we automatically group things that look alike. And prognons, or simplicity, means our brain always defaults to the simplest possible explanation. And the Olympic rings? A perfect example of this. You see 5 simple circles, right? Nobody looks at that and sees a bunch of weird, complex, interlocking C-shapes and ovals. Your brain just won't do it. It takes the simplest route. It's 5 circles. It's an absolutely essential shortcut for making sense of things fast.
So we've got all this incredible brain machinery, but what's the point? What is it all for? It's not just to create a nice, accurate picture of the world in our heads. The real reason perception evolved, its ultimate purpose, is to allow us to act in the world.
Think about something as simple as grabbing a coffee cup. It turns out your brain uses two totally separate pathways to do this. There's the what pathway, which runs to your temporal lobe. Its job is to identify the object, that's a coffee cup. Then there's the where or how pathway. It runs to your parietal lobe, and its job is to figure out the cup's location and shape so it can guide your hand to pick it up properly.
And the way we discovered this is just a wild story from neuropsychology. It involves a patient known as DF, who had damage to her what pathway. Now, if you showed her a slot and gave her a card and asked her to match the angle of the card to the angle of the slot, she couldn't do it. Her conscious perception of the orientation was gone. But if you just said, hey, mail that card through the slot, she could do it perfectly every single time. Her how pathway was totally fine, guiding her hand even when her conscious mind couldn't see what to do. Amazing.
Okay, so this brings us to the final and maybe the most important piece of the whole puzzle. All these different tools we've talked about, the top-down processing, the Gestalt laws, the separate pathways for action, they all serve one giant overarching purpose. Your brain isn't just reacting to what's coming in, it's constantly and actively predicting what's out there.
It's an idea that's really taken hold, summed up perfectly by the philosopher Andy Clark, who said, brains, it has recently been argued, are essentially prediction machines. Every single thing you experience is being shaped by your brain's best guess of what's about to happen. And there's actually a mathematical way to think about this called Bayesian inference. Now, don't worry, it sounds complicated, but the idea is actually super simple. Your brain always starts with a prior belief. That's its assumption based on everything you've ever experienced in your life. Then it takes in the likelihood. That's the evidence it's getting from your senses right now. It smushes those two things together to create its best possible guess about what's really going on, and it's doing that thousands of times a second.
You want to actually feel your own brain's prediction machine at work? Let me ask you this. Have you ever experienced the size-weight illusion? Imagine I hand you a big, empty cardboard box and a small, heavy rock that weigh exactly the same. Which one do you think would feel heavier?
Yeah, it's weird, right? Almost everyone says the small one feels heavier. So what's going on? Well, your brain has a very strong prior belief from a lifetime of experience. Big things are usually heavy. So it predicts the big box will be heavy, and it tells your muscles to lift with a lot of force. When you pick it up and it's surprisingly light, that mismatch, that surprise between the prediction and the reality, creates the powerful illusion that it's way lighter than the small object. That's you feeling your own brain's prediction in action.
So, what's the big takeaway from all of this? It's this. You don't just passively see the world. Your perception isn't a clear window looking out onto reality. It's an active, creative, and deeply personal process. Your brain is using a lifetime of experience and a whole toolkit of tricks to actively predict your world into existence, from the inside out. Join us again next time for another aha moment.